Hello viewers, welcome to another program on linear equations. Today we shall talk about system of linear equations, but before we do that, let's have a look at what a linear equation is. An equation of the type ax plus by equals c. An equation of the type ax plus by equals c is a linear equation. Here a, b and c are all constants, but be sure that a and b both together cannot be equal to 0, and the variables are x and y. I can assign any value to a and to b. If I give a particular value to a and particular value to b, then I get an equation 5x minus 4y equals 9, and this is nothing else but a linear equation in x and y. And we had also seen that when we plot the graph for this linear equation, what type of graph is there. The graph for a linear equation is always a straight line, and when we have to plot the graph, what do? First, we either make x as a subject or y as a subject, that is, we transform the equation either into x or into y. So let's have a look at the equations which I had. The equation is 5x minus 4y equals minus 1. So here I am making x as a subject, and I get from there x equals 1 upon 5 times 4y minus 1, and by assigning any values to y, I can get the values of x, and the different values that I get from there are, when I assign value to y as 4, I get the value of x as 3. So the first ordered pair we get for that is 3, 4. Similarly, by assigning the value to y as minus 6, I get the value of x as minus 5, and that is another ordered pair, and the third ordered pair is minus 1, minus 1. And then how do we plot them on the graph paper? On the graph paper, we plot them in a very simple way, that is, we plot the ordered pairs on the graph. Let's plot them and see what type of line does it come. So here I have 5x minus 4y equals minus 1, and the ordered pairs which are satisfying this equation are 3, 4, minus 5, minus 6, and minus 1, minus 1. And these ordered pairs which are satisfying this equation 5x minus 4y equals minus 1 are nothing else but the solutions of this equation. So let's plot these points on the graph paper. So the first ordered pair is 3, 4. So to plot 3, 4, I move 3 distances onto x-axis, 1, 2, 3, and for y-axis I have to move 4 units up, 1, 2, 3, and 4. So this is the pair, this is the point whose ordered pair is 3 and 4. Now let's plot the other ordered pair, that is minus 5, minus 6, and be sure that the first value in the ordered pair always corresponds to value of x, and the second value corresponds to value of y. Now since it is minus 5 units, so from the origin I will move towards left, 1, 2, 3, 4, 5, that becomes minus 5, and for minus 6 units, which direction do I move? Do I move upwards or downwards? The upward directions are taken as positive and downwards will be taken as negative. So I will go down. This is 1, 2, 3, 4, 5, and 6. So this is another point whose ordered pair is minus 5 and minus 6. Now although the 2 points are sufficient for me to plot a line, but the third ordered pair will let us know that whether these 2 points are correct or not. So we will plot the third ordered pair, and that is minus 1, minus 1. Again for minus 1 from the origin I have to move to left, this is minus 1, and that is 1 units down. So this point is minus 1 and minus 1. So let's now join them with a scale. So on joining these points by the scale, I find that all the 3 points are in the same straight line. Now if I happen to take any other point outside the line, let's take this point. Can you find the ordered pairs for this? The ordered pair for this point is 1 unit on x-axis and -1 unit. So this ordered pair is 1 and -1 and -1. So can you tell me now that 1 minus 1 will be the solution of this equation or not? So let's put that in the equation and see whether this equation becomes a true statement or a false statement. So that is 5 times 1 minus 4 times -1. So that makes it 5 plus 4, and that is equal to 9. But what is the right hand side of my equation? That is -1. So but this, the solution of the left hand side is coming as 9. So naturally 9 is not equal to -1. So what do we find? That the point which is not on the line is not the solution of the given equation. So that was the one equation. And how did we get the ordered pairs for that? And this plotting that we had learnt in the last lesson, and we had very quickly had a recap of that. But in case I have two equations, the equations being 5x minus 4y equals -1 and 2x plus y equals 10. So these are the two linear equations, and these two linear equations together will form a system of linear equations. And the general format for the system of linear equations is a1x plus b1y equals c1 and a2x plus b2y equals c2. Again, a1, b1 and c1, they all belong to set of real numbers, and a2, b2 and c2 too. But you have to take the precautions that a1, b1 simultaneously cannot be equal to 0, and also a2 and b2 cannot be simultaneously equal to 0. So in case we have to solve the equations of this kind, what is to be done? We will follow the same technique, that is, we will be converting both the equations into either x or y. That is, I will be making x or y as a subject for both the equations, and then I will be getting the different ordered pairs. So let's see how we do that. So here is the first equation, 5x minus 4y equals -1. So from here I get x. Here I am making x as a subject. So x is equal to 1/5 of 4y minus 1, and the ordered pairs which are satisfying this equation are 3, 4, -5, -6, -1, -1. And for the second equation, 2x plus y equals 10, I have made y as a subject. Now this has been done purposely, because if I make y as a subject, I am avoiding fractions. So whenever you have equations, always see that when you are transforming it either into x or y, if possible, see that the fractions are avoided. So for these, the ordered pairs are 4, 2, 5, 0, 2 and 6. So when we have a system of equations, that is, a system of equations means two or more than two linear equations will form a system. And obviously, since one linear equation gives us a straight line as its graph, the second linear equation will also give us that. So let's plot these lines onto the graph paper and see how these two lines look like. 5x minus 4y equals -1, and for these the ordered pairs are 3, 4, -5, -6, -1, -1, and the other equation is 2x plus y equals 10, and the ordered pairs are 4, 2, 5, 0 and 2, 6. Now if I ask you a question that whether 4, 2 ordered pair will satisfy this equation or not, obviously yes, because we have already calculated this point, this ordered pair, by transforming this equation into y. Now let's plot these two equations onto the same graph paper. Now the first line, for the first equation, the points have already been plotted, 3, 4, minus 5, minus 6, and another point is minus 1, minus 1, and this is the straight line which is representing the equation 5x minus 4y equals minus 1. Now let's plot the graph for the other equation, that is 2x plus y equals 10. For this, ordered pairs are 4, 2. 4 units again we move to the right of the origin, 1, 2, 3, 4, and 2 units up. So this point is 4 and 2. The second ordered pair is 5, 0. So for 5 units, 1, 2, 3, 4, and 5, and since the other point is 0, so I need not move up or down. So this point is 5, 0. And now let's plot the third point. The third point is 2, 6. 1, 2, and 6 units. Where do I go? Up or down? 6 is positive, so I move up 1, 2, 3, 4, 5, and 6. And this point is now 5, 2, and 6. Now let's join these points by the scale. So here what do you find? That these two lines are intersecting at one point, and that point is over here. To get the ordered pairs for this point, I have to plot the perpendicular onto x-axis and onto y-axis. For x-axis, this is one distance, and here is the other distance. So how do I get the ordered pairs at this point? So to reach at this point, I have to move 1, 2, and 3 units horizontally and in the positive direction, and 4 units, 1, 2, 3, and 4. 4 units up. So this point has the ordered pair 3, 4. And what is the beauty of this point? This point is lying on this line as well as on the other line. So that is, this point is such a ordered pair which is satisfying both the equations, that is 5x minus 4y equals minus 1 and 2x plus y equals 10. So this ordered pair 3, 4 is the point, is the ordered pair which is satisfying both the equations. So here when we plotted the graph for the two equations, we found that the two lines are intersecting at one point. Let's have a look at the graph once again. So here the two lines are intersecting at this point. Is there any other point where these two lines are intersecting? Obviously there is no other point where these two lines are intersecting. So this point with ordered pair 3, 4 is satisfying the first equation whose line is over here, and the second equation whose line is this one. This point is present in both the lines, hence we say that this point is a solution for both the equations, and hence this is a solution for the system of equations, and the system is 5x minus 4y equals minus 1 and 2x plus y equals 10. So here we saw that when the two lines plotted on a graph paper, they intersect in a point, the ordered pair corresponding to that point satisfies both the equations, and hence it forms the solution of the system, and hence it forms a solution of the system. But now let's have a look at another system, and here the equations we are taking are 4x minus y equals 13, and the other equation is 8x minus 2y equals 26. Transforming the first equation into x, we get x equals 1 over 4 times 13 plus y, and the ordered pairs corresponding to this are 2 minus 5, 4, 3, 1 and minus 9. And for the second equation, 8x minus 2y equals 26, x equals 1 over 8th of 26 plus 2y. The ordered pairs for this equation are 4, 3, 3 minus 1, 5, 7. Now once again we will plot these ordered pairs for the two lines, two equations on the graph paper and see how do these lines look like. So here is the first equation, the 4x minus y equals 13, and the ordered pairs we are taking for this are 2, minus 5 and 4, 3. So let's first plot these 2 points. First point is 2 minus 5, again 2 being positive, I will move to right, 1, 2 and minus 5 units. Which direction do I go? Up or down? Because it's a negative distance, I will be going down. So this is 1, 2, 3, 4, 5. So here is this point which is 2 and minus 5. Let's plot the other point, that is 4, 3. 1, 2, 3, 4 and 3 units positive being we move up 1, 2, 3. So this point is 4 and 3. So corresponding to the first equation I have this line . Now let's plot the points for the second equation. Second equation is 8x minus 2y equals 26 and the ordered pairs are 3 minus 1 and 5, 7. To plot these ordered pairs for 3 minus 1, this is 1, 2, 3 and minus 1 units I will move down, minus 1 is here. So 3 minus 1 where do you find it is? It is on the line itself. The other order pair is 5, 7, 1, 2, 3, 4, 5 and 7 units being positive again move up 1, 2, 3, 4, 5, 6 and 7. So this point is also lying on the previous line. So what do you find? Here the ordered pairs for the first line and that of second line, they are lying on the same line. So what can we say? Here in the previous case when we saw the lines were intersecting, but here the two lines are just overlapping each other. So that means how many ordered pairs are there on this line? There are infinite ordered pairs, that is many ordered pairs are there, and all those ordered pairs will be satisfying both the equations, that is 4x minus y equals 13 and 8x minus 2y equals 26. So this system 4x minus y equals 13 and 8x minus 2y equals 26 has infinite solutions. So here we plotted the graph for two systems. In one case we found that the lines were intersecting and the point of intersection was a solution for the system, and in another case we found that the two lines were coinciding with each other. So that means all the points on the lines were the solution for both the equations. So we can summarize this as, in case there is a one solution or many solutions, such a system will be termed as a consistent system. And for a consistent system, if we happen to plot the graph will be either intersecting lines, and the point of intersection of the lines, that will be the solution of the system, that is it will be satisfying both the equations. Or there will be many solutions when the lines are coincident, in that case both the lines will be coinciding with each other. So these are the two cases when we saw that the system is consistent. A consistent system can have one solution or it can have many solutions. But let us take now another case of a system of equations and plot their graph once again. So here the system with me is 3x plus 2y equals 12, and transforming into y, I get y equals 1 by 2, 12 minus 3x, and the ordered pairs corresponding to this equation are 0, 6, 6 minus 3, and 4, 0. For the second equation, y equals 3 over 2 times 9 minus x, and the ordered pairs for this are 5, 6, 3, 9, and 7, 3. So let's now plot the graph for these ordered pairs. The first ordered pair here is 0, 6. Now 0, 6 means I don't have to move any distance onto the x-axis. So this is 0, and 6 units I'll move up, 1, 2, 3, 4, 5, and 6. So this point is 0 and 6. The other point is 6 minus 3. 6 units being positive, I will move towards right, 1, 2, 3, 4, 5, 6. Now if I don't move up or down, this point is 6, 0. But I want the point 6 minus 3. For minus 3 units, which direction do I move? I will move down, 1, 2, and 3. So this point is 6 minus 3. On joining these 2 points, I will get one straight line. And this straight line represents which equation? This represents 3x plus 2y equals 12. Now let's plot the graph. Let's plot the ordered pairs for this equation. They are 5, 6. 1, 2, 3, 4, 5, and 6 units I will have to move up. 1, 2, 3, 4, 5, and 6. This is the one point, and the other point is 3 and 9 units. 3 units onto the right of origin, 1, 2, 3, and 9 units I will move up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this point is 3 and 9. Again joining these 2 points, so this line is a x plus 2 by 3y equals 9. So what do you observe in these 2 lines? Are these lines going to intersect anywhere? This line and this line? No, they are parallel lines. So that means neither they are coinciding nor they are intersecting. So will they have any solution? Obviously not, because they are not intersecting at any point. So these 2 lines are not intersecting at any point, so hence they have no solution. So such a system which has no solution, that is called an inconsistent system of equations. So a system having no solution will be termed as inconsistent system, and if we happen to plot the graph for such a system, this will be parallel lines. So here we found that basically there are 3 types of systems: the consistent with one solution, or a system having infinite solutions is also a consistent, and if we have a system which has no solution, that is called an inconsistent system of equations. So once again let us revise that what is a system of equations. For a system of equations, in case we happen to plot the graph, the intersecting lines will be representing one solution, that is, that ordered pair will be satisfying both the equations, and if the lines are coincident lines, then the system will have many solutions. The coincident lines means all the points on the line will be satisfying both the equations, and when we get the parallel lines, the system is considered as inconsistent, because it has no solution. So, the system having no solution is called as an inconsistent system, and when we plot this such a system onto the graph paper, it is represented by two parallel lines. So, today we learnt about the system of equations and their graph. In the next lesson, we will talk about the algebraic method of solving the system of equations. Until then, goodbye.